So, excuse me, sorry. So 6-7 day 2 homework, page 433, 37 through 43 odd. So when we're going through these types of problems, whether it's a fractional exponent or a normal, square root or cube root, our first objective is to always make sure that we get that radical or that term entirely alone, right, by itself. So in all the problems that you had to do, and I'm kind of just outlining 37 and 39 for right now, make sure that you get rid of any addition and subtraction, any kind of multiplication and division to completely isolate that term. And then if you remember from Friday, what we do from this point is then raise each side to the reciprocal of whatever that fractional exponent is. Now on your homework, each reciprocal was a whole number. That's not always going to be the case. In fact, there's a question not only on the check-in, which we'll get to after this, but also on the quiz on Friday where you have to raise it to a reciprocal, and that reciprocal is also a fraction. All right, so make sure that you're aware of some of the simplifying methods to kind of break those terms down. After that, you have your easy 1 and 2 step equations where you add or subtract over and then multiply or divide to get your variable by itself, right? Your answer, which you'll be able to kind of just type in, should just be a whole number, okay? So you see here numbers 37 and 39, okay? Does anybody have any questions about either of those? For 37, you should have got p equals 3. 39, you should have got x equals 83. Are there any questions about either of those two problems? Okay. 41 and 43 are here. Very similar to the first couple. Be really careful with your simplifying. One thing that I saw on a couple people's homework assignments as well as in the check, make sure that when you are raising both sides to the reciprocal, you are using it as an exponent, right? So some people might have like multiplied the 3 and the 5 here instead of raising 3 to the 5th power, right? So when you're simplifying, just be aware of what you need to do on either side. 43, also you have multiple steps. Remember that 3 in front is not a part of that isolated term, right? So we need to divide both sides by 3 in order to get that entirely by itself, all right? Are there any questions about 41 or 43? For 41, you should have got z is 61. For 43, you should have got x equals 3. Any questions at all about this homework assignment? Okay. So now we're going to transition into is that 6-7 day 2 check. So if you're following along here, if you go to the 4th marking period folder, and then you go to today's folder, Monday 5/3. As I said, for those of you coming in, make sure that you have a device ready to go that you're following along with. The first thing that you'll see there is the 6-7 day 2 check. So I want you to click on that and then complete both of those questions there. I believe there's a time limit. I think it's 12 minutes or so to get each of these problems done. I want you to do this kind of on your own, but I'll be around to help you if you have any technology issues or anything like that. After we are done with this check, we're going to go over each of the problems just to completely finish section 6-7. Hopefully give us a better understanding of these ideas. And then we're going to transition into the review material for today, which is section 6.4. All right. That is the sheet that is out in front of you that you can follow along with. All right. And for those of you that are at home, after you get the day 2 check done, I would suggest, downloading or printing section 6.4's review, which is in the folder for today as well. All right. So take the next 10 to 12 minutes or so and go through that day 2 check. After you're done, and I see that everybody has submitted their answers, we'll go over it. It is fill in the blanks, so make sure you just type in your answer, right? You don't have to type in x equals since it is already there for you, okay? Did you get this done? The check's already done? What's that? Gotcha. All right. Yeah, you're good. Yeah, you can go. Yeah, so what we just went over, yeah. So that's what you're doing. That's what you're doing. No, they're gonna grade automatically. Yeah. What's that? Yeah, if so long as you submitted it, yeah, you're good. Yeah, so once you're done, just submit your answers and then you can go ahead and just like kind of those of you that aren't here, obviously, those of you that are at home, you need your Chromebook still to follow along or your laptop, whatever you're using. For those of you that are here, you won't use it. So. Ben, did you submit yours? Okay. Looks like I got pretty much everybody's. So with that being said, we're going to go over each of these problems now. All right. So give me just 1 second to share my screen again with those of you that are at home. Okay. So these were the two problems that you had. Very similar to the homework assignment from last night and what we saw back on Friday. All right. The first thing that we need to do is make sure that each term is isolated. All right. So this is problem number 1 here at the top, problem number 2 at the bottom. All right. Is my term isolated in number 1? Oh, sorry. So is my term entirely by itself in number 1? Do I have to add or subtract anything over, or do I have to multiply and divide anything over? No, right? So my term is by itself. I need to raise both sides to what power? 3, right? The reciprocal of that term. So I have to raise it to the 3rd power. All right. When I do that, my exponents are going to cancel. What's left over on the left-hand side? The 2x minus 1. And then what's 3 to the 3rd power? 27. So that's all right. So if you multiplied those together, that might have been a place where you made a mistake. Remember what I said when we were going over the homework, that you need to raise it from one power to the other. Well, from here, I have a 2-step equation. I'll add 1 to both sides. So I have 2x is equal to 28. Divide by 2, I have x is equal to 14. And then that would have been my final answer. All right. So x equals 14 should have been one of your answers. Are there any questions about that first example? So the first question you would have seen on the check. All right. Second one's a little bit more complex. Same question to start. Is my term that's being raised to the fractional exponent entirely by itself? No. So what do I have to do on both sides? Subtract 1. So I have 2x plus 1 to the 3/2 is equal to 27. What power do I have to raise both sides to? 2/3, right? The reciprocal of that fraction. And the reason I do that is because when I raise a exponent to another exponent, I multiply them and these cancel out. So I'm left with 2x plus 1 on the left-hand side. On the right-hand side, I have 27 to the 2/3 power. Well, that means that I'm taking the cubed root and then squaring to 27. So what we talked about back on Friday is rewriting this in radical form, so it's a little bit easier for us to see what's going on. I have an index of 3, and I'm squaring it. Another thing that we talked about on Friday as a review is to take care of the root first, right? You get the same answer if you did 27 squared and then take the cubed root, but it's a lot easier for us maybe to do mental math or work with some smaller numbers if we do the root first. The cubed root of 27 is what? 3, and then what's 3 squared? 9, right? So then I have 2x plus 1 equals 9. If If I subtract 1 from both sides, I have 2x equals 8. Divide by 2, I should have got x equals 4 for my final answer. All right. So that was just a mini check-in with section 6-7, right, for day 2 of that lesson. I would expect to see a problem very similar to number 2 on the quiz on Friday, where you raise it to both sides, but it is also still a fraction. Okay. Any questions about either of those examples? Bless you. Bless you. To check your answer, what you could have done was plugged each of those back in. So if you get to, a point on Friday where you have a lot of time after the quiz and you want to make sure you check your answers before you submit it, if you plug 14 back in, bless you, you would have gotten 27 raised to the 1/3 power is equal to 3 after you kind of simplify through. Well, that's the cubed root of 27, which we know is 3. So I would have gotten 3 equals 3 on both sides, right? Good way for you to make sure that you have the right answer. If you have the same thing on both sides of your equation sign, that means you got the right solution. In the second example, if you plugged in 4, you would have gotten 9 to the 3/2 power plus 1 equals 28. Well, 9 to the 3/2, and that's after simplifying, is the same thing as the square root of 9 to the 3rd power. Well, the root of 9 is 3. 3 cubed is 27. You would have gotten 27 plus 1 equals 28. So 28 equals 28, and you would have gotten the right thing there. So make sure that if you have time, you go through and you check your answers to each of those solutions also. All right? Everybody good with that concept? Okay. We're going to transition now into the review for today. So this sheet that those of you that are in here have had out in front of you for a little bit. Those of you that are at home, you can access this in the folder for today. All right, shown that a couple times now. We're going back to section 6.4. So we did this about 2 weeks ago, I believe. All right, so it should take a little bit of time to refresh ourselves with, but the concept itself is not overly difficult. And you will see one question at least like this on Friday for the quiz. All right, so make sure that we're aware of the steps. We're just simplifying these expressions. All right, so this is one of the first concepts we talked about in chapter 6. The first thing we need to do is make sure we identify our index. All right, we had three steps for this. Identify the index, take that root, whatever the index is telling us, of a constant term inside my radical, and then work with anything that has an exponent with variables, right? So if I'm looking at example 1 here, I have the square root of 121y to the 4th power. Well, the first thing I want to do is identify my index. My index here would be 2, although it's not written, I know I'm taking the square root, right? We've seen this many times in this chapter. Then I go to the constant term inside my radical. Well, I'm taking the square root of 121. I know that that is 11, right? Just take it step by step. Identify the index, take that index or that root of your constant term, and then work to any variable with an exponent, right? I have y to the 4th, but I'm taking the square root. Well, when I have a variable raised to an exponent and I'm taking the root of that, it's the same thing as writing that variable to the exponent divided by the index, right? And we talked about that frequently in chapter 6 when we were going in between radical form and exponential form, right? The only thing I need to make sure I take into account now is how I simplify this, because I know 4/2 is the same thing as 2 itself. So my final answer here would be 11y squared. Okay. Any questions about that first example? Okay. So what I plan on doing is going through all the odds together as a class. So hopefully as we continue to progress through, it'll be a little bit more collaborative, and then the evens you'll have for homework, okay? So number 3, what is my index? What root am I taking there? 3, right? My index is 3, so I'm taking the cubed root. I go to my constant term. What is the cubed root of 8? So what number can I multiply by itself 3 times to get 8? 2. And then from there, I have x cubed, and I'm taking the cubed root of that. Well, how's that going to simplify? 1, right? So it's x to the 3 over 3, or just 1, y to the 6 over 3, right? Which is just 2. So it's 2x y squared. Good. Any questions about example 3? Example 5, what's my index? 3. Do I have a constant term here in example 5? Is there anything I need to take the cube root of? No, right? So I just move right on to my variable terms. Well, I have x to the 9th power. I'm taking the cube root of that. How's that going to simplify? X cubed y squared. Good. Right? X to the 9 divided by 3, y to the 6 divided by 3. Well, that's going to give me x cubed y squared. Any questions about number 5? Number 7, a little different now because we have a fraction underneath our radical. Our steps are still going to stay the same though, right? I identify my index. What's my index here? 4. So I'm taking the 4th root of whatever's inside my radical. Well, I would suggest just working with your numerator first and then your denominator. And then again, still working from constant term to variable term. All right. So what is the 4th root of 81? 3. Okay. 3 times 3 gives me 9, times 3 gives me 27, times an additional 3 gives me 81. So I have 3. And then I have x to what power? Because I have x to the 8th, but I'm taking the 4th root. So squared from 8 divided by 4. In my denominator, do I have any constant terms I have to worry about? No. So then I have y to the 16th, taking the 4th root of that. How's that going to simplify? Y to the 4th, right? 16 divided by 4, or just y to the 4th. Yeah. Let's go over this one. Let's just finish this one first, though. So in number 7, I have 3x squared divided by y to the 4th. From here, what I would suggest doing is just making sure you can't simplify any further, which I can't in this example. Sometimes maybe if there was another constant term underneath and it's simplified to maybe 6, right? Then you know you have x squared over 2y to the 4th from simplifying those constant terms, right? So just kind of be aware of all the simplifying. Question that came up in here about number 8. Notice that we have a negative underneath our radical, okay? Now, this shouldn't throw us off because the first thing we need to do is always identify what? What's that? Well, constant terms, right? But the index, right? I want to know what root I'm taking. So something we talked about earlier in class was if I have an even root and I have a negative under my radical, I have to take an I out and simplify it. But if I have an odd index, I'm taking an odd root, and there's a negative underneath, I simplify normally, right? It's just going to happen that whatever number the cube root is going to be negative. So what is the cube root of just positive 8? 2, right? Well, the cube root of negative 8 would just be negative 2. Negative 2 times negative 2 gives me positive 4. But then positive 4 times an additional negative 2 is going to give me negative 8. So it'll be negative 2. And then my constant term, or excuse me, my variable terms will simplify normally. So I have the cube root of x cubed, which is just what? Just x, right? X to the 1st power. If you weren't sure, like say a question like that came up on Friday or on your homework, whatever it may be, and you took each of those terms and multiplied them together that many times, you should get what's inside your root. So -2 times -2 times -2 is -8. X times X times X gives me X cubed. So that is what's inside my radical there, just a way for you to check. And that goes for any problem, really. You can do that for any of the ones that we've covered so far. All right. Any questions about anything on the first page? Okay. Go to the second page. So hopefully we're in a little bit of a groove now with this. Number 9, what's my index? 2, right? It's not written there, but I know I'm taking the square root. What's the square root of 144? 12. And how does x to the 4th, taking the square root of that, how's that going to simplify? X squared, right? That comes from x to the 4th divided by 2, or x squared. Any questions about number 9? Number 11, what's the index? 3. Excuse me. I'm taking the cube root of 64, so I start with that constant term. What's the cube root of 64? 4. Good. 4 times 4 gives me 16, times 4 gives me 64. How is x to the 6th power taking the cube root of that? How's that going to simplify? X squared, right? From 6 divided by 3. What about the y terms? Just y, right? Y to the 1st power, or just y. So 4x squared y. Any questions about number 11? All right, 13. What's my index? 4. Start with 81, right? Taking the 4th root of 81. What's the 4th root of 81? 3, right? We saw that back on the first page. 3 times 3 gives me 9, times 3 gives me 27, times 3 again gives me 81. And then I have x to the 8th power taking the 4th root of that, y to the 8th power taking the 4th root of that as well. How's that going to simplify for each of those two? X squared, y squared, right? Just doing 8 divided by 4. Any questions about 13? Okay. Last one, number 15, and then we'll discuss the homework assignment for tonight and kind of the rest of the plan for this week. 15, what is my index? 3. What is the cube root of 216? 6. So the cube root of, or 8, excuse me, the 3rd power will give you 256. Cube root of 216 is 6. And then x to the 6th taking the cube root, how's that going to simplify? Right, x squared. So it'd be 6x squared. All right. Any questions about anything from the second page, anything at all from the 6-4 review that we went through as a class?
I guess we're doing all evens then, right? Since we just did like LP odds.
Yeah, so good comment. It's going to lead into what I'm about to explain for the homework tonight. So you see here, 6-4 review, complete all problems not done in class. So you're going to go through and just do all the evens for your homework for tonight. All right. So good question. When you come into class tomorrow, what we'll do is we'll go over all of the even problems. So everything we did not get done today in class. And then we're going to transition into more review with section 6.5. So there is a decent amount of time here still at the end of class for you to get that assignment done. And then for those of you that are at home, I would suggest taking a look at, oh, sorry, hold on a second. Give me 1 second here. I would suggest taking a look at Tuesday's folder and making sure that you access the 6-5 review, because that's what we're going to be doing tomorrow in class. So we'll go over the 6-4 review, and then it'll be very similar. We'll do some practice problems from this review as well. And then whatever we don't get done in class, and you see there, it's probably going to be evens again, will be due for homework. Tomorrow's review, just to give you a heads up, is on rationalizing denominators. So remember that when we are simplifying our expressions and we're dividing by a radical, we don't want to have a radical inside my denominator, right? So we're trying to get rid of it. And there was a couple different problems and different scenarios that we saw with that we want to make sure we go over. Pretty much every day will be the same. So we'll do some problems in class. Your homework will be whatever we don't get done. And each problem that you see in class will probably translate, or will definitely translate, I should say, to a question that you'll see on the quiz. So make sure that if you have any questions at all, you reach out. So, you're ready to be successful on the quiz come Friday. All right. Any questions for me before we wrap up here? Okay, still a good amount of time. Those of you that are here, I would suggest getting the homework done and then submitting it. Those of you that are at home, enjoy the rest of your day, and I will see you all tomorrow. All right, take care.
Have a good one.
You too. See you later.
See ya.